let's go ahead and talk about section 9.2. And section 9.2 is about absolute value equations and inequalities. Now, the first thing we need to do in section 9.2 is understand the definition of absolute value. What exactly do we mean by absolute value? Now, absolute value basically means that is the distance of the number from 0 on a number line. Okay, that's your definition. The absolute value of a number is the distance of that number from 0 on the number line. So let's say we have these two numbers, positive 2 and negative 2. If you look at the graph, you will see that you have 0 in the middle. Now if you look at positive 2 is 2 units from 0, so that's your distance right over there. Same thing happens with negative 2. You're on the other side of 0. And again, if you're talking about the absolute value of negative 2, you are saying what is the distance of negative 2 from 0, and that's 2 units. So if I were to put this in an equation form, you have absolute value of x equals 2. The solutions for this equation will be positive 2 and negative 2, because again, remember, both positive 2 and negative 2 are 2 units from 0. What happens if we have an absolute value inequality? How do we work with those? So let's look at an example for that here. Let's say we have this absolute value inequality. Absolute value of x is greater than 2. What exactly are we talking about here? We are saying, what can the value of x be if that distance is greater than 2? So just like we talked in the last example, if this was x equals 2, then your two solutions for x would be a positive 2 or a negative 2. But here, in this one, we're talking about the absolute value being greater than 2, which means that your distance has to be more than 2. If I put that in a graphical form, this is what you can imagine it will look like. You're talking about values of x being greater than 2, which means all the values greater than 2 will have a distance of more than 2. On the negative side, all the values that are less than negative 2 or smaller in value with negative 2 will have a distance of greater than 2. So if you're talking about the solutions of x greater than absolute value of x greater than 2, your solution set will look something like this. We're saying the solution set will be from negative infinity to negative 2, not including negative 2, and the interval of 2 to positive infinity, again not including 2. And this says any number, you can have a positive 3, you can have positive 6. All of these numbers have a distance of greater than 2. On the negative side, you can have negative 10, and again negative 10 has a value or a distance of more than 2. Okay, now we've talked about the inequalities, compound inequalities with the word or. Anytime you have an absolute value equation of the form greater than, your solution set will be described using the word or. So you can describe it as x will be either less than negative 2 or x is going to be greater than 2. Okay? Now let's look at what if we had absolute value of x less than 2. What would that represent? Now let's say we have something of this form. Okay, absolute value of x less than 2. So in this case, we're talking about what values of x will have a distance less than 2. So of course, if you look at it graphically, you are saying any number which is between 0 and 2, not including 2 again, will have a distance of less than 2. On the negative side, anything between negative 2 and 0 will have a distance of less than 2 again. So in terms of your solution set, you can say any number between negative 2 and 2 will be part of your solution set. Again, you can see we are not including negative 2 and 2 in our solution. So anything between these two numbers will satisfy our inequality, absolute value of x less than 2. Now, if we were talking about this in terms of a compound inequality, you can see that we are saying that the value of x is going to be contained between negative 2 and 2, not including the endpoints. So as a compound statement, you can write it as x is going to be greater than negative 2 and x is going to be less than positive 2. Again, if you look at this in terms of the graph, x is going to be greater than negative 2 and x is going to be less than positive 2. Okay, so that leads us to the discussion of absolute value equations and inequalities. Now, if you were writing this as an equation or an inequality, you would probably see something of this form, where you have absolute value of ax plus b equals k, or as an inequality, you can see it as absolute value of ax plus b greater than k, or absolute value of ax plus b less than k, where of course your a, b are going to be real numbers and k is going to be a positive number. Now, if we take this above examples that we saw, and let's say we have something of this form. You have absolute value of x equals 4. Again, as I said, we saw above that this would have the same solution set as x equals negative 4 or x equals 4, which again tells me negative 4 and 4 are 4 units or have a distance of 4 from 0. If I'm going to write this as an inequality, I can write it in this form, where you can have absolute value of x greater than 4 will have the same solution set as x less than negative 4 or x greater than 4. Again, always remember, when you have the greater than inequality symbol, you use the word or to show your solution set. And when you have the absolute value of x less than 4, the less than symbol will associate with the word and your solution set will be x is greater than negative 4 and x is less than 4. So keeping these examples in mind, let's go ahead and solve some of these absolute value equations and inequalities.